I'm Thalen. I'm from Portland. Computer science major. I just do a lot of like full stack. I just like messing around, seeing what works, and trying new shit.
I think for humility purposes as well, which is super useful, the person who invited the person who came has to introduce them. So for example, because you're going to be humble as well, Sean, you can introduce Thalen as well to people being like, he's won 3 hackathons, he's done X, Y, and Z as well.
Yeah, sounds good. Probably the most, the freshman with kind of like a builder and project manager / leader architect and initiator architect. Probably the most talented one I've met so far yet. Technical wise, he's not technical.
Yeah, I'm using Excel.
Copy paste and ChatGPT prompts.
So true.
I'll just start introducing someone else now.
Sure.
She has 30 million users on TikTok.
Hey, that's not users, that's
Fuck.
That's Maxime.
Followers.
Okay. Maxime has 100,000 users on Whisper. Paying user, yeah?
Things got paid.
Okay,
If you
well.
had 100,000 pages,
Sorry. 100,000 people that are very invested in Whisper. And that's how you say it. You say it like
Free users.
Max, do you have an ad for Whisper? Because like,
it's cool like that.
she should do the voiceover for
That's
your
what
ad.
I'm saying, bro. I'm like, whenever somebody says Whisper, they have to say Whisper.
We're not 11 left.
Yeah.
So funny. We need a version that's like fast too.
We're speech to text, we're not text to speech.
I can introduce Ryan. Ryan has over 14 years of entrepreneurship
How old are
experience.
you?
20. Yes. If you do the math as a business major, you'll know that he started before he was 10. Correct. That's how math works. Ryan's very heavily invested into VCs and the financial side of entrepreneurship as well. Really wants to help out and build out Trump as well to have a bunch of connections to potentially fundraise, pre-seed, seed, eventually when we get to that stage in the next coming months, years, and time as well.
Andre, Aiden, he is extremely dedicated towards solving really hard problems, not like the easy problems, but like really hard technical problems. He has experience in the philosophical but also very technical sides of things and has done a lot of really impressive things, but I can't quite.
Yeah, basically. This is good practice because we'll have more people come in and we should introduce more. And every single time someone new comes in, you have to introduce a different person than the one that you introduced last time. It's like that. So we know each other.
Oh, do we optimize for speed or optimize for like?
Right now, because
we optimize for efficiency.
So both.
Impact per time.
Yeah, basically
The
focus on,
rate.
like, the biggest achievements as well.
I think your movement of just extremely hard problems you're trying to create a quantum computer right now, like that movement is the most impactful.
What? Now I introduce someone.
Yes.
Who hasn't been introduced?
There's a ton of
Like,
people. Yash,
people.
Enrique, Raj, Neil, Michael.
Who do I know best? Who do I know least?
Andre, you
That's the
can
real
introduce
question. Probably Michael I know least.
Okay.
Michael is the founder of AI Collab, which is one of the biggest technical clubs on campus.
Thank you.
He is a Bio-E major, and I knew that without reading the slide for sure. And he works with your boy Tran, which instantly means that he's great. And he's working on plant savers, which is a very important and interesting topic, and he's cracked at it.
Thank you, Aiden. I'll go ahead and, okay, I'll introduce Andre, yeah. So I first met Andre at Chalkboard. I remember I was discussing, I think you mentioned, you gave me an interesting idea. I was talking about how upset I am at the Bio-E department, and you recommended that I actually try to improve the Bio-E department, which will long-term benefit me, you know, by giving them feedback. That was a very interesting idea. So that speaks to your character as someone who wants to improve things and kind of views things from that angle. You know, you're very accomplished winning many hackathons, the NVIDIA hackathon, and getting into FR8. You know, it's a huge accomplishment, and you're going to do great things. And yeah, it's a yeah.
Awesome. I already introduced Ryan, so I'll let someone introduce Enrique, Yash, Raj, or Neil.
What?
Yeah, yeah,
Wait, who
I
hired
was not
Maxine?
ready.
Maxine never did
yeah,
that.
Maxine, you never introduced.
Oh, Raj, okay. What can I talk about? What can I
Why is this all way
Pick
recorded?
what we have done together.
Okay.
Yeah.
Yeah. No. Okay. First, Raj is the person who able to solve any technical problem. Any. Yeah. Even not solved by OpenAI yet, if he wants. First point, diligent. I appreciate a lot of stuff here. Second point, able to manage stuff by himself without being pinged. Please utilize the following skill from him. Yeah, so we're working on Vivora now. Thanks God we found people to iterate fast in development. Yeah, so honestly, by working with Raj, stuff goes smooth. Much more smoother than in Whisper. Yeah, so that's like basic overview of Raj. Pretty, let's say, technical operations.
I'll take note. Let's see, working on an agentic social network has done many projects in the past. Competitive wrestling, I think, yeah. From Connecticut. Yeah.
Okay, let's go. Build the hometown.
Pretty good. Pretty good. I have high confidence he will succeed in life.
Oh yeah.
If he doesn't go to jail.
Yeah.
Over
Crashing in
under
across now.
1.5 people from Chalkboard going to jail throughout the life.
Oh my god.
100%
Definitely.
Over 1.5.
Wait, what?
Isn't it?
What?
I don't know.
Pick someone.
Okay, Yash. He is from India. He's from like the projects in India. The Indian projects. He's a very resourceful person. He, like, in terms of like economic mobility compared to everyone here, like I think I think like most everyone at the school actually, I don't know, but like the levels he's jumping in the world is insane, and that can be attributed to his amazing interpersonal human skills and his intuitive approach to approaching problems. So he started a bunch of problems he started a bunch of companies in India, you know, had that all entrepreneurial experience, and ever since he's come to the United States, he's managed to wrestle his way up to where he is now, and that is very impressive to me.
This is a genius idea. We should do this all the time.
Yes.
Virgin.
Get everyone gets
Sorry.
glimpse at least
Does
once.
the blinking mean it's muted, or does the blinking mean it's not muted?
The blinking means it's muted.
Okay. He just pressed the button. We did not know, sorry.
So wait, none of that was captured?
No, it was.
It's captured over
So
here.
we have another recorder. So Raj, yes.
There's still Enrique and Virgin.
Introduce.
To be honest, I do not know a lot about Enrique.
I got you.
We haven't.
Brasileiro.
What's up with
Me and Enrique go a long way back. So name is Enrique the Mellow, live where I probably butchered that. And okay, wait. Shoot, that's a long
Faster.
bro. But he first did his internship at Ergo Work, then he did private equity research at Greenfield Research Partners, then he did. Then he was an analyst at Battery Ventures, then he was a product manager at Premisa Security, then he was an analyst at Santa Clara Investment Fund, then now he's GTM in partnership at Crawl AI.
He works
Come on, bro.
Yeah,
Use some
like
sense.
this.
Don't just read it all.
He is satisfied.
Put a little personal flair on it.
Is he decent or satisfied?
So to speak, what you
Jesus.
Portuguese?
The highest level of competition.
He's Brazilian.
Oh, that's awesome.
Yeah,
is like
besides,
satisfactory.
he called Sam Altman decent. So.
Sam, in the last events.
Is there anyone above decent for
And
you?
there's only
Besides
one other
you.
guy who
Some
rocks
Altman.
the glasses in this room.
No, 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 no.
Off camera, that's someone who loses virginity.
And off camera.
So can I go with Birkin as well?
Yeah.
I'm last guy.
Wait, doesn't Enrique introduce Perkin?
Oh yeah.
And Sean, you been here?
Yeah, did anybody introduce Sean?
Sean.
Okay.
Okay, I'll do Perkin. Yeah, I met Perkin with, I guess, chalkboard. I walked in here and then immediately there was a camera in my face. No, I'm kidding. Yeah, I don't know. I mean, he does something that I could never do, which is just like content generation. I mean, yeah, it takes a lot of guts to like film stuff and put your content out there, and yeah, I think it's really cool.
Thank you, Perkin.
In case Birkin has all data against us.
Yeah, bro. Do you remember your birthday, the conversation that we had on Maxine's birthday in that librarian room, bro? All of that shit, bro. 10 years down the line, we're gonna be.
What's actually
Okay,
it's gone.
Actually, do you know where all of the
Perkin
copies
is
of
actually
stuff
espionage. He's interested in human.
Or
Perkin, you know those like torture experiments where you lie in the chair, you have a napkin, they pour water over you? Like, I need you to.
Waterboarding?
Yeah, that. I need to make sure that the content that we have recorded never goes out anywhere.
Bruh.
If it's like in one way, just like harming to anyone. In this room.
And it is.
Alright, now Sean.
Okay. Should I introduce Sean?
Yes.
So I know Sean. Like what? Lazy?
Blaze, yeah.
Bro, you have done so much in the past. How would I be able to like? Sean.
Good,
have,
good, just like that.
Like,
He likes that. Just like that.
Sean is like a genius. Like wins so many hackathon and like don't even have to try. Like everybody knows Sean was gonna win and like got internship in NVIDIA and
In
like
a hiring freeze.
yeah and like like Jensen will want to have a dinner with Sean as well. Like
Wait,
it's
actually?
crazy.
Wait, that's crazy.
Really?
Wait, what?
Wait, what?
Oh, you made that up.
He's manifesting, guys.
Yeah. Okay.
Also,
There's
lots
some-
of like really professional people who really respect you. Like,
Yeah.
and that is
The connection.
People appreciate it.
And he's kind of cute.
Okay, bro.
I agree.
That's a little too much. Like,
Yeah.
Gosh.
Time out of the
It's
room.
Jensen, come on. No, one sec. Bro,
What?
can you take me as well?
I'm trying.
Wait, in all honesty, Sam Altman at the AI Summit in October.
We have 3 friends.
What's friends?
Like potential like connections to school.
Cool. In case I'm willing and able
That would be
to act.
What about Andrew Mays? Crazy.
Yeah, that's what
Maxine's like helping protect him.
Have you seen his TV show? Have you seen his TV show?
Oh yeah,
No.
I saw that one.
Oh, trust Andrew Main.
Is it still going? Or is it? Oh.
A long time.
The Shark Boy?
No, he did
Oh.
one where he did like pranks on like I guess people in public.
I'm gonna search that up after
Yeah.
this.
Look it up. Don't trust Andrew.
Bro,
Main.
we've all said
Don't trust him.
outrageous stuff throughout our lives.
Oh, okay.
People in their past.
You're
No,
asking
no.
us not to
No,
trust
they said
Andrew
don't-
May.
Wait.
No, that's the name of the show. That's
Oh,
the
okay.
name of the show.
Oh, I thought you were saying like
Interesting.
he's unreliable. I was like, wait, what?
He did some like fucked up pranks. That's how.
Bruh.
Like what's one?
Yeah, this is Shark Boy, bro.
Yeah.
Okay.
Funny thing you mentioned Shark Boy and
This is
Lava
the.
No,
Trailer.
Shark Boy, like he would try to be eaten
Free.com,
by
Google
sharks.
Games.
There's one season.
Shall we shorten it or same pace next time for introductions?
That might be tough.
Short man, for sure.
What's the goal?
I mean, from just now, I feel like everyone kind of
It needs
broke
to
down
be
a lot of
like
barriers. I think
boom,
that was
boom, boom. I think it's also
Not
like an
like-
implicit feedback thing.
Mm.
I also want to like the whole purpose of it as well is people are very humble, which is like a good thing, but B we want to showcase.
Not always here.
No.
Yeah.
I was gonna
true.
say I highly disagree with that.
Some people are more humble than others.
Okay,
Just wait, let me finish. So, but when you introduce other people, you're able to show their best qualities in a short amount of time, so that for newcomers they can see their talent as well.
If that's the goal, also like we've had people say things in a very forgetting the word like unheightened way, and other people are always around them and say, actually, this person's legit, which heightens it, which makes it theoretically, if
Well,
that's the
like
goal,
credibility.
it doesn't make that
Yes, it becomes more credible from another person.
Like, it's a lot more credible, but we still reach that same point no matter what. So I'm like, is the goal like community and breaking down batteries as fast as possible, or is the goal instead having the trust, but also the trust also can come from that other system, then maybe it's not necessarily coming from this.
Well, also, I feel like people are just closer to other, like to some people more than others. For example, I'm closer to Sean than I am to like Raj, let's say, right? So
Max
maybe
is-
just, like, Raj would be better.
Guys, we spent on this 25 minutes.
Hmm.
That's like, I think, the main argument.
No, we didn't.
No, we did not.
Yes, we did.
Yeah, it's 1732. We didn't start at 1707.
We started at 17:15.
Well, 15 minutes. Okay, 17.
This is the
That'd be different.
last time when we introduced ourselves, it was also 15 minutes.
No, I just want to
Yeah.
say the following. So, I
13%
think
of this whole thing.
I assume, guys, that everyone here is legit, and when people come, they need to assume that everyone else is legit. Yeah, obviously we can validate it. I would be honest. I'm fine if people presenting themselves. If you believe that person didn't state some main achievement, like Andre says, like, oh, we're computer science major, so you can add that Andre won 3 hackathons. It's okay to like explicitly state this and like add data points. But when we're introducing each other, we're like retaining data. It's not as efficient because like in terms of the flow, people still, let's say, attempting to operate and choose, oh, who I'm presenting. Did they tell everything about it? Then the jokes come up. Again, today's like more or less chill atmosphere. We don't have a lot of people. When we have guests,
Like 20 people in the room.
yeah, when we have 20
Yeah,
people, it will take an hour. Yeah, it's also important. Last time we spent this amount of time because we had 20 people plus, and now we have definitely not 20 people.
What do you mean? It's literally the same thing. It's not that hard. You just
Uh,
introduce
if
the
we're-
person to the right of you or whatever, and you
You're
just go
probably able
around.
to. Oh,
Yeah.
I think like 30%, like if you just do it under 30 seconds, it'll be fine. Or like maybe 20 seconds to give
Yeah.
yourself a timer.
We're gonna do for sure. I'm not against.
Yeah, but even
Just
then, if
like-
we have a
Yeah.
lot of guests, they're not gonna like, know the person next to them, right?
You just
Yeah,
Last
yeah.
time we had, like,
Well,
a lot
anyone
of
who's
guests,
new
you
introduces
know?
themselves.
Okay.
Okay.
A lot of people inviting them.
And I'll like someone that found them adds like an anecdote maybe.
Yeah.
Okay, awesome.
Yeah.
Anyway.
It might be also efficient to go in a circular manner than jumping around. Cause
Yeah.
The person
Like,
on your
send
right.
it to the right or whatever.
Okay. Sick. Let's try optimizing this one.
Yeah. All right, should I get us started?
Take it away.
All right, so I'm gonna talk about my senior design project that I've been grinding over like the past year, and I dropped a lot of other things such as AI Collab for this project. I should preface, I've been getting more into agriculture starting this year, but I'm still definitely not an expert. So if any of you guys are, have background in agriculture, some of these things are currently like controversial and debated about. So like feel free to jump in and give your opinions as well. But yeah, so this is my group. We're called the Plant Savers. I don't know if, I'm trying to do this. Shit.
I mean, we can just move.
Yeah, let's do that.
That's right, it works.
All right, fuck it. I'm not gonna touch this. This group is a bunch of interesting people. Lucas is in this group, but not like officially. He has his own project. And then 2 underclassmen, 1 junior and 1 sophomore, are both on this project. Oh, you know Ishin? Yeah. Working under Dr. Zhang, an amazing bio professor, Dr. Tran, you know him, and Dr. Whittall in the bio department. So it's very whatever. The School of Engineering gave us $500 to work on this. Typically, they'll get 1,000 plus, so we were kind of shafted, but we still may do. We have a lot of collaborators. I'm actually collaborating with the Vienna University of Technology. Without them, this project also probably would not have been possible. And I've worked with a bunch of different professors from ELN to MEC to physics. This is probably not super visible, but essentially my project is taking place in the fact that by 2050, the world's population is gonna increase by 20%, but to match that increase, we need to increase our agricultural output by 50 to 70%.
Or efficiency in getting that output to people.
Okay, yeah, so probably political trade routes, dealing with tariffs and
some increased marketing spend.
Yeah.
It's like a
Okay, yeah, okay, that's actually what I'm, yeah. So, okay, yeah, we could make more food or just save more food.
Yeah.
And so my project is doing the saving food part. And okay, to do that, we need to figure out where is food actually wasted and lost. And so this is kind of the chain in North America. We're losing about 20% of all of our agriculture at the very first step of just like before harvesting it. So this is due to weather, pathogens, or just like economic constraints. As you go forward, right, there's harvesting it, there's processing it, distribution, and then the actual consumer level. We're losing around like 30% of all of our food like at the consumer level. And that just means like people waste their food because they just don't eat it and it goes to spoilage, yeah.
So like the 30% that's lost at the consumer level, is that 30% of what they received or 30% of the original?
30% of what they received. So each step it's losing like that percentage. Yeah.
Okay.
But if you start at the very root, there's that 20% right away. And
is
yeah.
that 30% at the end bots? 30% bots?
Yeah.
30% consumed? Because I know there's lots of programs where something then is close to going bad and they give it away for free to these homeless shelters. I'm not sure if that confuses.
So yeah, maybe there's like programs like that. This is like, you know, this has been sitting in your fridge for like, you know, however many weeks and you didn't eat it. So you're just gonna toss it. It just gets wasted. And of course there's programs, but like not a lot of people do those. And so I'm targeting that initial 20%. And to start somewhere, I started with a specific pathogen called Aspergillus niger. Essentially, it infects a bunch of different crops. It actually kills 10% of all peanuts in the entire world, which is actually an insane amount. And just those are some other crops. And to make a solution for this, we have to look at how we already deal with like pathogens in agriculture. And so there's kind of this cycle of where you start at like the knowledge and data spot where you just get data about whatever pathogen is in your crop of fields. Then you kind of get insights, how much of this pathogen has spread to my fields, etc. What do I need to deal with this? And then you actually just take the action. Pretty simple, like apply fungicide or something. And I'm making a solution for the data and knowledge step where we're just detecting various like problems. And thus, I'm trying to develop essentially a sensor that collects data about Aspergillus niger. And some of the competing technologies that already exist, there's a bunch, like there's PCR, which is, you require pre-processing. I'll get into that. Like there's also like visual inspection, which is actually really common. That's what a lot of farmers do. And just like they pass it down from generation to generation from like their grandfather's grandfather knows what it's supposed to look like and shit like that. But there's essentially just a bunch of problems with all the different technologies that are out there, whether it's kind of complex to use, whether it's costly, whether it's just like not accurate. And so my goal essentially is just to develop a rapid sensor that is accurate, it's cost effective, requires no like pre-processing, which is a huge or very important thing for Aspergillus niger spores. Okay, so now I'm going to get into the actual science of my project. So this is the layout of what a biosensor fundamentally is. You need a receptor to like attach to whatever your biotarget is. You need a transducer to essentially convert the energy of your receptor attaching to the biotarget into an energy you can read. And then all the later stuff, just like ELN stuff, I didn't really do too much there. And to start off with, the bioreceptor I'm using is something called an aptamer. And these are literally just short strands of DNA. You think of DNA, it's making your proteins or whatever, but DNA has lots of other properties, such as it can very specifically bind to things. And that's what aptamers are. It binds via hydrogen bonds, electrostatic forces, just all the different forces there are. And the benefits is they're really inexpensive, they're super cheap to make. They're really reproducible from batch to batch, and they are less sensitive to the environment. So like, you might think antibodies typically for like things like this or enzymes, but the problem with those is they're very sensitive to temperature or just pH, whatever it is. Aptamers are very sturdy. And you could think of it literally, it's just this DNA strand attaches to these tiny little spikes and it attaches to the whole thing. Yeah.
How do you bind with both hydrogen bonds and hydrophobic interactions?
So it varies from aptamer to aptamer. Like one aptamer might mostly be using, one might use hydro. Good question. So that's just the bioreceptor. So then I'll talk about the actual transducer part. I'm using something called a quartz crystal microbalance. Essentially, this is like a very tiny like mass scale. It can detect mass changes on like a nanogram scale. It's been established typically for like developing computer chips, right? Because you need a very thin film of material applied to the surface. So that's why people might use a QCM. And you know, this is just saying it's already been established. There's an equation typically used for it. Also, it's just a piezoelectric crystal. If you remember from physics, if you apply electricity to a piezoelectric, it applies a mechanical force to the crystal, and vice versa. If you apply mechanical force, it converts into electrical energy. Yeah.
Question. I blanked before you started talking about this
Oh, good.
transaction pathway. What is this pathway for?
So this is the transducer. So okay, we need to convert the energy of a receptor binding to the biotarget into something we can actually read, right? And the way we do that is using a transducer, and that transducer I'm using is this QCM. So when my receptor binds to the spore, that's going to create a mass change that I'm going to detect using this, okay? And okay, so this is just describing a little bit about how you actually record information from a quartz crystal microbalance. How many are like ELN kind of a little bit? Do you know what S11 parameters are?
What, you mean like the poles and the transfer functions?
So okay, S11 parameters are just like, you'll send, you know, like RF energy. So like, I'm essentially sending an AC current at like 5 megahertz, the top and bottom part of this QCM. Because there's going to be like a change in impedance, that's going to obtain some like reflectance back to well, okay, I'm using a network analyzer. And that's what the S11 parameters are related to. It's the reflectance coefficients. And we can use these parameters to actually measure these mass changes on the surface of this crystal, okay? And so we should know about this crystal is it has a resonant frequency just due to like the physical like design of it. And when we have these mass changes on the surface, that will actually shift the resonant frequency, because you can think about like it creates some inertia because this crystal is literally shaking. So when it attaches, it's like an inertial force that gets applied. Okay. Sorry if this doesn't make any sense, but like I'll try to have like more. I have more. Yeah. So here's how you could think about it. Here's our crystal. There's mass that is attracted to the surface of the crystal, and this resonant frequency literally just shifts. That's what the data should look like. Okay. Here's just another diagram, right? So here's my crystal. I am. Okay, so how I'm combining the two is I'm going to immobilize my aptamers from before onto the surface of this quartz crystal microbalance. And essentially, the spores are just going to bind to the crystal, and we're going to see this frequency shift. Okay, that's the basic idea. Yeah.
Why are you trying to see spores?
Why am I trying to detect spores? Yeah. So the reason I want to detect spores is because that like provides well, okay. Specifically, like let's say you see a problem on the crop field, like you don't know actually what that exactly is. So you'll want to test that sample and see what it actually is. You would run it through my sensor, and you could detect if it actually is this type of fungus or if it's, you know, if it's not. Yeah.
How do you detect specifically these spores and not A, anything else that might bind,
yeah,
or B, just like dust?
Yeah, so that's actually what I'm gonna get into in a little, like just a couple of slides. But the one thing to remember is aptamers bind specifically only to its target.
Wait,
so,
sorry.
Yeah. No. Yeah.
What was it? Can you define aptamer one more time?
Yeah, aptamer is a very short strand of DNA, and you might think of DNA making proteins, but DNA can also just bind to things. And so this aptamer that I'm using, actually from the Vienna technology, blah, 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 whatever, it's going to bind only to Aspergillus nigrospores, nothing else. And okay, here's just some of my own data. This is like just fluorescence imaging showcasing I was able to immobilize the aptamer successfully onto my little chip over here. And to get to your question, so one thing you'll see is there's a bunch of gaps in between all the aptamers, right? Dust or something could just land in there and cause that type of frequency shift that we might see. And the way I'm here's kind of a diagram of what it looks like. Here's this R piece is my aptamer, and there's these little holes in between all of my aptamers, right? So dust just gets inside those little holes. And the way I deal with this is we add like a backfilling coating of 6-mercaptohexanol, which essentially just attaches to all the like blank areas on the chip and fills it up so that nothing else can like get close to the surface. So it's just these aptamers on this top part attaching to these spores, nothing else.
So what, they're electromagnetically repelled?
Yes.
So wouldn't this still transfer the force to the surface though?
It might very slightly, but if we have the spore that binds to the aptamer, that force of that is so much greater than the tiny like static repelling forces. Yeah. Okay. Here's like maybe the electrical engineering part, just like signal processing. This is essentially what my raw data looks like. And this dip right here is where my resonant frequency is actually located. Just to be able to like calculate that, I'm just doing a Gaussian curve fit to find that center of that curve. And if we plot that over time, again, that's going to look like this resonance frequency shift. And okay, I've essentially put my sensor together. I have to test if it actually works because I don't want to be Elizabeth Holmes or whatever her name is and be fake about my actual sensor working. Okay, so I start with a positive control. That's just essentially, does my sensor actually detect spores? And this experiment, what you're seeing right here, is this initial part is like blank media. It's PBS. There's nothing in it really other than ions. Then in this red region, that's actually when I introduce spores. This one is a very high concentration. I just wanted to make sure it worked, and clearly it's shifting. It's actually shifting around 180 hertz, so that's a very good signal. Next, I want to do negative control. This is testing if random things actually cause noise or show up in my data. And to do this, I used E. coli to test my sensor, which is a very similar size to the Aspergillus niger spores itself. And essentially, same thing. Green part is the blank media, red part is the E. coli, and clearly it does not really shift at all. There's a slight shift. I want to go back and look into what's actually happening there, but we're not seeing that downshift as we saw from the spores. And it's actually a higher concentration of E. coli than the spores that I used before. Okay. Finally, I developed a titration curve, which essentially just allows me to calculate concentration with respect to the actual signal I'm getting. I tested with 1,000 spores per milliliter, which is insanely small. You can't even see that. 10,000, 100,000, and then 1 million. This is the data that I got, and essentially this just allows me to calculate concentration with my, with the readings from my device. That's very helpful if you want to diagnose the severity of maybe the problem. Okay, so here's the summary of my project, right? I had $500 to develop this biosensor. Reduced non-specific binding, that's the problem that I talked about before. I had a limited detection of 1,000 spores per milliliter. We get data or like results within minutes, and there's no pre-processing required. You can just take it and put it into the sensor directly. All good, all good. I think also this is recording as Perkin has, yeah.
I just wanted to get your summary, it's cool stuff.
Thank you. Next steps, right? I want to actually like make it usable, get a UI, incorporate into agrobots. This is the rover in the RSL lab. And I also want to increase the amount of pathogens that I can actually detect because I developed a platform technology. This was one specific pathogen. With this platform technology, I can expand it to hundreds of different types of pathogens, which is why this is also impactful. And also just kind of thinking about big picture, and I want to talk a little bit about my own philosophy, is that I think, in the world of AI or just robotics, right, we're somewhat limited by one, I guess, the computing power, but two, the actual data we can get. Like, there's only so much data on the internet, for example, right? And it increased at somewhat of a rate, but if we can get also different modes of data, that's very powerful. Like, think if humans existed without sight, and then all of a sudden we have vision, right? That's a different sensory modality, and that's extremely powerful when we get new information from that. I kind of believe that in the future we will need to develop new sensors to get more information from the actual world in order to more effectively make decisions or interact or whatever it is. And that's kind of my own thinking and mission for my own next 10 years. I want to develop new sensors, new modalities of actually detecting the world, the chemical and biological world.
Cool.
Yeah. Okay, yeah, that's pretty much it. Thank you guys. Yeah.
So this technology is very impressive.
Thank you.
I got a question.
Mm-hmm.
Are you the only guy who's figured this out, or are there other people who are trying to approach this market, this business, this technology, this problem with this technique that you have?
Yeah. So I don't know if other people have the same philosophy I have. The QCM technology, that's been established. However, and here's another point I didn't make. The current gold standards for QCM technology is 3,000 plus. 3,000 is probably the least amount of money you'd need for this technology. I developed this in under $500, and I can make it for even less. So
Scalable?
Scalable, manufacturing wise, I have no clue. I just made one of these. I haven't thought about that at all. But I did. I 3D printed a lot of these parts. Yeah.
Two quick questions, right? I remember one of them. One of them is, can you apply this to other types of diseases and biomarkers?
Yes.
Personally, for me, it'd be cool if I could test my testosterone by spitting into a tube.
Yeah.
I feel like there's a bunch of yeah.
No. Yeah. That's yeah.
Oh, yeah, valid.
Valid.
I can test my BDNF, my NGF, all
Yeah.
my different biomarkers.
Yeah.
And what I mean.
Building on that, at Startup World Cup, there was a company that won actually in the regionals. You just have to breathe out in a mask, and it senses 300 diseases that you could possibly have just by your.
And you're basically kind of following I don't want to sound like an idiot, but I'm trying to draw an analogy, the mRNA technique, where you just create some kind of biocatalyst thing that can react to a specific, I forgot the biological term, but you create a specific molecule,
and
it comes out another one.
Yeah.
Right?
Yeah.
So that goes into my next question.
Yeah.
There's all these different markets, which I'm assuming you want to go into at some point.
Mm-hmm.
How, are those catalysts domain restrictive enough? With those, what are they called in biology? I forgot the term.
The receptor and the analyte, or
yeah, I guess,
and ligand.
Whatever,
okay.
The male and female or whatever.
Okay. Yeah.
Right. The substrate. I don't know.
Okay.
But
yeah.
That thing, right? If you create a sensor based on one particular substrate, will it get interfered with other particular possible matches to that?
Yeah.
How do you determine accuracy? Signal.
So you need So you're talking about right now this bioreceptor step of a biosensor. And your bioreceptor needs to be specific to the exact target you're looking at. So if you want to detect specifically testosterone, you need a bioreceptor that specifically binds to testosterone. That's, I guess, that's essentially, it's like the key in the lock kind of fit.
Right.
And there's lots of problems for why, there might be other things interfering with that signal. That's one of the things I tried to address in my project as well, and I did address that. Yeah, I guess you can expand it to different targets that you might want to look at.
Yeah, that's what I was.
Have you tested how robust it is over time, seeing if the coatings degrade at all? As well as testing in noisy conditions. If you were to put this on the front of an agricultural robot, it would be getting some wear and tear, presumably.
Yeah, absolutely. Yeah.
Have you done any testing for that?
So I haven't done that. I've just done this preliminary work to establish that it works. But that's something I would want to head towards. And at least typically with aptamers, they will last about a month. Antibodies or enzymes, they last maybe weeks, days, something like that. That's why I actually also want to use aptamers, because they can last for longer. Yeah, I guess, yeah.
And do you have concerns about macroscopic particles, affecting it, even if you have this coating on, if it's just dirt and dust, it's sort of comes in, like, I'd imagine this coating can't repel if I just sprinkle sand on the thing.
Yeah. No, that's true. That would definitely be a problem. And I'd probably want to like either apply some filter in the very beginning or have some type of flow that prevents or minimizes the amount of like. Oh, actually, another thing is the cleaning detergent that's used for this is important because once I actually run a sample through, I applied a cleaning detergent to get rid of anything that was previously bound or on the chip. So in that case, like if there's dirt or something, I would just want to optimize the cleaning detergent that
Right, so
runs.
you'll
Yeah.
wash it, but the spores will stay bound even when you wash it.
No, but the spores, I want the spores to leave once I wash it because I want it to be continually usable. I don't want it to be work once, then you have to get rid of the chip.
You're reusing it, but that doesn't help with the measuring process, differentiating between, right? If you had a solvent that washes
I see.
everything
Yeah.
but spores,
Yeah.
you could just wash it before you test it, and then you.
That's true. Yeah. Yeah, maybe I'd want to have something that doesn't get the spores but everything else, and then the second step is regaining of the spores. Yeah, it's a good idea. Yeah. I haven't thought too much though, but yeah, that's good thinking. Yeah.
Would you call this like an innovation in the assembly of like current technologies, or would you call this like some form of breakthrough somewhere? I don't know. A more fundamental innovation.
So, I think one of the biggest things is I made this like really cheap and accurate. Like, there's one other like setup for this that I found for like maybe $500, and it doesn't. I tried to make it doesn't work. So I think that's one of the biggest things. That I just made a $3,000 technology work for like maybe less than 500. I think this is also for me myself a breakthrough because first time I did this, but I'm wanting to start developing new technology, and I learned a lot personally from this. Yeah,
no, this is like super cool. It's like
Thank you.
starting to piece everything together.
Yeah, your
like,
fellow
it's, like,
Bio-E.
learning. Yeah, I'm like, oh my gosh. But like the price is awesome because I know with farmers like that's a huge thing.
Yeah, all the equipment's like millions of dollars. Yeah.
And then another application that you could potentially use this for, like an idea, I don't know, but like personal use as well for like individual people. I know like people that have I don't know, like next year I'm gonna have fruit trees, so you can like scan. I don't know, would that be applicable to like on smaller scale, like people buying them to see what's wrong?
So I think, are you saying like, can this also be applied to humans and healthcare?
No, like plants as well.
Uh-huh.
But I mean, I would assume this could potentially, that would be a lot harder to like FDA, but like, yeah, like personal plants. Like,
like at home, like, okay,
yeah.
Yeah, I'd imagine, like, you can do that for like personal plants. I don't know how valuable it would be because like I just imagine for farmers, right, they care so much about crop yield. Like that's their number one thing. And for like, it could be entering that market somehow. Yeah.
So you said that you use the 3D printer to make it right now really cheap. I'm curious as well, if you're looking to develop this into a scalable solution as well, I assume you can't really stick with 3D printers, or?
Yeah, like if I wanted to like have some like injection molding or something, probably. Yeah. To be completely frank, I haven't thought like that far ahead yet. And there's lots of things about this design that I need to optimize as well. Like this, it's first prototype.
Is there anything that got, I guess, compensated because you used the 3D printer in terms of quality, potentially, that is either quantifiable or not?
Yeah, so like the very detail of like some of like, so with my sensor, there's lots of like more intricate like parts on the inside. Like so the detail of those things kind of is affected, especially like the flowing of my sample through in and out of the design. But I think other than that, like I think like one of the biggest things is that I made this work for such a cheap price. And like, I think it's because I kind of approached how to like essentially how to design this holder in a different way than most people have done. Like most of the companies have used like complex spring-based kind of systems to get a very even distribution. Anyways, Yeah, shoot. Yeah, sorry. Yeah.
I got another question. Are there like different techniques? Because I'm assuming there's different ways to perceive biological phenomena. Like one is like the simple camera method. Like if you're looking for pathogens on plants, for example, like what if advanced computer vision algorithms be more effective than like catalyst-based bioreceptors?
Yeah.
And then after that, there might be like certain like laser optometry. I don't know if I'm using the right vocabulary.
Yeah.
But
No.
laser optometry
Yeah.
technology that can like basically refract with biochemicals in a particular way so that you can detect
Yeah.
it.
I know what you're talking about.
So
yeah.
like those techniques, would that be something that you do? Is that something that might be less efficient, more efficient?
So the problem with visual like recognition or using cameras is just like the accuracy of it. Like I'm sure if you could get to a certain point with computer vision, but like you won't 100% know if that pathogen is a certain pathogen because like different like funguses and different bacteria can get similar looking symptoms in a plant. I guess another problem with computer vision is like if you just change the angle sometimes it fucks the whole thing up. So yeah, like even like daytime, nighttime, you know, random shit like that. So there's a problem with that. So when you're talking about the lasers, there's one thing called hyperspectral imaging. That's super fucking expensive. It also, I mean, it can be, like it's been good for like, you know, monitoring plants, but you need like gigantic like satellites or I saw like a handheld kind of device. You kind of swipe the plants, but that's more like looking at, to be honest, like plant stress or like plant, I guess I've seen it be used for like plant stress typically.
So you kind of just like rub it on the stock?
Yeah, like you just take like a little swab or something if you see that on your plant, you just swab it and put it into my sensor and then, yeah.
If you see, so you said part of it is seeing.
Yeah.
So you need for the seers to also be using this product.
So, okay, right now the product would be, you see that and you swab it. But one of the things that I also wanted to do and why I also was starting with spores is because I want to develop something that can just capture it in the air. So before you even see the problem. I tried to do that initially. It's a bit complicated. So I'm starting with just the swab part. Okay. But that's something that I want to get to eventually. You don't even need to see it. Okay. You just detect it in the field. Yeah.
Is it localized often?
Like pathogens?
Yeah.
So yeah, depending on the region, you'll typically see, or traditionally you typically see the same pathogens in certain regions. However, like with a lot of actually, like this is actually one thing that climate change is affecting is like pathogens actually spread around much more easily. And so there's random outbreaks more often of like pathogens that historically haven't been in a certain region. So it's becoming more risky for farmers. And that's why this would also be like risk management in a way, I guess. Yeah.
Oh, no, sorry.
I'm thirsty. Can I have some water?
Yes, absolutely. Are these regions like a foot, or are these regions like multiple?
This is acres. Acres to like an entire state.
So
Thank you.
Your goal would be, there's this pathogen in this state, and then a farming company decides not to invest in this state or this place and instead goes somewhere else? Or is it found on a farm and I need to get rid of the 10 crops that are within this area?
So for like if we're on the field, the use would be you can detect it super quick and apply fungicide as quick as possible so it does the least amount of damage. The longer this pathogen is hanging around, the more damage it's going to do. So that's the first application, but there's also other problems where like, you know, there's growth while like a crop is in storage or being transported from A to B in like a truck. So also having sensors in there can help you identify like which truck might have an issue, and then you can apply some type of, you know, like fungicide while it's inside of the cargo, rather than once it gets to B, you see what looks fucked up and toss it out once it's at like let's say we're exporting to Canada. Like once it gets to Canada, they just like look at the crops and toss it there. You know.
Do you see that if you look at all problems that plants have, not all problems that could stop it from succeeding, from getting from point A to point B, is there one sort of strategy which solves all the problems? If I can do one thing to it. Even if it's really expensive and using cameras, but it sees everything this plant could have, versus if your thing doesn't fit into that. I see a very easy way if you have one solution for everything, so it just has to go through a video or it has to go through the sensor. Even if it's really expensive, instead of having lots of different types of checks at every single point,
I see.
even more expensive and even more timely.
So if you can have like one device that can capture everything, but it's super costly. I guess.
Just like what is it right now? Like, is it like, okay, you have all these different types of checks at every single different place?
So like current technology is kind of like that. Well, you'll take like a swab or something and you'll kind of run it through various tests to see what it could be. The problem with those tests right now is that they either require like some pre-processing, so you have to like do a couple like amplification steps or whatever it is, I mean, yeah, that's pretty much the current technologies. Other than like visually looking at it, or you take a swab and you have it grow and you then see what it is, but that takes a couple of days for it to grow. So like that's also a problem.
So swab basically solves all the problems right now.
I think to my like understanding, yes, that's like the most common thing. There is like the light technology, but like honestly, the light technology isn't a one problem solves everything. Like light is very good at being specific, but like to a point, you know.
One last thing. For this, is the people who are in charge of this, is it one person who says everyone need to have these steps, or is it one person who has a company which says we need to focus for these exact specific problems, and then it's sort of like a privatized, or is it more opposite?
Okay, I don't know if I understood that very.
If they care about certain things, then they might only have certain solutions. Versus if a government or some sort of agency says you have these solutions, which encapsulate full data of something that could have an impact on your placements in this ecosystem. So I'm just curious about
like, is there regulations?
Who has power over regulations?
Well, consumers won't eat plants with fungus.
Oh no! So is that the government? Who's?
Oh, like who filters out? Oh, who filters like what is allowed versus not?
Yes. Not necessarily what's allowed with the systems, which makes the right food get to the right people.
So, okay, there's a couple different checkpoints. So one checkpoint is going to be like once you just harvest it, like the people will sort it out right away.
So
that's the farmers. But there's multiple steps. So then there's like, I'd say a big step is actually the distribution part. That's where it actually gets to the supermarket. The supermarket will decide like, okay, what actually just like looks nice, like good enough to sell. And if it doesn't look good enough to sell, they're just going to toss it. And that's another step. It is like there are regulations, governmental regulations. I don't know if it's the FDA or if it's like the USDA. And I don't know exactly what steps they intervene though. But it's somewhere between that, you know, ecosystem. Yeah.
I think the like Food and Drug Administration.
Yeah.
If that's what you're at, like the more the rules that are then passed down to I believe the farmers get that notice too, of like what from the FDA, right? Like they have to abide by.
Yeah. To be fair, like I'm not super familiar with that territory, but yeah, I'm sure at each step there's some type of rules that, you know, prevent like shitty food from getting to the customer. Yeah.
What's the sensitivity and specificity of your test, and how does it compare to the more expensive options?
So yeah, my sensitivity or like limit of detection right now is 1,000 spores per milliliter. The current technology, I'd say the current technology is a bit more sensitive than my device. For specificity,
what does a bit more mean by?
I'd say it could get down to like 100.
And is that a big
difference?
That plays out significantly
So,
in real scenarios?
If we're trying to detect the spores in the air, that's pretty important.
Right.
If we're detecting it, from that, no, it works perfectly fine. Yeah.
This could be. Sorry.
So if you move on from like the swabbing and you're detecting them in the air, then you're getting these spores in the air. But how do you know like originally where they came from? Like if you're detecting on like a state level basis, that's fine. But if you're going like field by field, like, I don't know how far spores travel, but could it be that like, you know, a sensor here detects that something's wrong, but that spore really came from somewhere else? Like,
Yeah, I see what you're. So like the direction of it. Yeah, it's a good question. I'd imagine like, let's say you want to try to identify where it came from, you'd probably want to put various sensors around your field. So if sensor over here and here found spores, but the other sensors didn't, it's most likely in that region, you know?
okay,
Yeah.
this is really cool.
Thank you. Yeah.
Sorry, I might have missed it, but like, there's like a strength part of it as well? Is that?
So the limit of detection, that's, right now mine's at 1,000 spores per milliliter.
This could be something cool you sell to robot companies. Sorry.
Yeah, ag robots, yeah.
So then, like, you could have, like, essentially, it be, like, more infected in one area than another in yours, or no?
You can measure that with my sensor, like how, what is that? Yeah, how many spores there are, yeah.
So then what's the, like, infected, like, if there's any spores, then is it, like, they're gone, or, like,
So,
what's the threshold?
yeah, that's a good question. It's kind of, okay, like when you get really down to like the very small amounts, there's going to be just stuff in the air regardless. So I guess the threshold for that is something I'd probably want to look into more.
Well,
Yeah.
correct me if I'm wrong, but the issue is you don't actually know, technically speaking, that it is spores. Like, you've engineered it to collect spores, but unless you run like additional tests, you're just like, we got, you know, basically X, you know, amount of mass of things that we think are spores, judging by this frequency difference. So when it gets down to low enough, then you can't say, you know, outside of uncertainty, that it isn't some other shit finding or something happening.
Yeah. But the device I have developed is, at the moment, like, for the experience I've done, it is quite specific.
Right.
Outside of, like, let's say we flooded it with dust or something, you know. Like, it won't bind to other biological targets, at
But
least.
that's not nearly as big. I didn't realize you were doing swabbing. I thought it was like out collecting open air, which is why I was asking so many questions.
Okay, yeah. Fair enough, yeah.
Air. That
Yeah.
makes sense.
Do insurance companies use these?
So, insurance, I don't know, like, just to say off the bat, but like, as I've been learning more, like, about the ag field in general, like, insurance is a pretty big thing. And I did talk to one person who works at an insurance, like, seed company, and they felt that, like, a technology like this would be very beneficial, because then, you know, they would be able to say, okay, well, you know, this maybe field has a higher probability of getting, you know, some spore or something, or some fungus. But yeah, initially, I don't know. Yeah.
Are they allowed to do that?
I don't know.
Okay.
Yeah.
Because it might be like some discriminatory.
Yeah, there would
like,
probably.
Smart, like,
yeah.
they should, but
Not
like,
anymore. It's the U.S.
I think there's no way they're not doing this right now. Like, if I was an insurance company and somehow I'm able to look at, use any data that I have, then like, if I can say, okay, hey, farmer, put this on your land, and I'll be able to have more data, which means I'll be more likely to be able to give you more money.
Yeah.
Or to ensure your crop yields.
Yeah.
Which would make it good for the farmers and good for the insurance people, because they can more accurately
Yeah.
tell from data that this is going to be lower risk.
It's a really good question. The thing I built was targeted towards the farmer and increasing the farmer's yield, but potentially that application would be something that's used right now, but I wouldn't know about it. Yeah. There also, I mean, there's probably some consent thing where, like, yeah, the farmer has to be like, yeah, you can put it on there. Yeah.
Let's probably cut it here.
Okay. Yeah. Thank you guys.
I don't think we have any other orders of business, so no walk today probably. I don't know unless if anyone wants to.
Walk home.
Let's go home. You should.
Congrats on this.
Thank you.
Like,
Thank you.
I feel like
Thank you. Thank you.
between learning and like creating, there's some like there. I feel like
For this?
No, just like in general with information. Like there's a difference between like learning new things and applying them different ways versus kind of like, I don't know, creating
new information.
Almost.
Yeah.
synthesizing.
Well, that's what I'm very interested in, is like creating new modalities of information that we can sense.
Oh, by the way, on the image versus sensory